Hello and welcome. I'm very pleased to invite Ascendance Flight Technologies to talk about next generation aviation and particularly how the future of aviation will be more sustainable. So Jean-Christophe, welcome. Could you please give us a brief introduction about you, Ascendance, and your vision for transforming aviation?
Hi, Mylène. Sure. So Ascendance was founded in 2018 with one conviction that the future of aviation will be sustainable. And one mission is to develop the solution to decarbonize aviation. So today, Ascendance is developing two products. One is an aircraft, an alternative to helicopter called ATEA that takes off vertically like an helicopter and cruise like an aircraft. It has very key advantage because we save up to 80% of carbon emission and we divide by 4 the noise. We can use it for people transportation, we can transport up to 4 people, and we can use it for logistics, for medical services or surveillance. The second product we are developing is called Sterna, and it is an hybrid technology compatible to any energy sources that will be the future of aviation, be it the sustainable aviation fuel or the hydrogen. And this hybrid technology today, we offer it to other aircraft manufacturers to help them to decarbonize themselves and hybridize their aircraft.
Thanks for this introduction, and it's really a unique approach. It's commonly agreed that there's no time left to tackle the challenges for net zero aviation. It's fantastic to see Ascendance proposing and demonstrating a solution with a very short-term application and impact. Of course, there is no silver bullet to cope with and to move to more sustainable aviation and to cope with a carbon budget consistent with the Paris Agreement. We must be mindful that air traffic volume will be an active topic in the debate, and today we will focus our discussion only on the technological level. It's admitted that the technological levels are split over different parts, and particularly the first one, the more impactful and the biggest one, is decarbonizing the energy source by switching from fossil fuel to low carbon energy, like sustainable aviation fuels and hydrogen. Secondly, on increasing the efficiency, and with two ways. First, on technology, with improvement on incremental changes like on aerodynamics, materials, engine performance, or with more disruptive improvement with new aircraft architecture or new engines, and also improving efficiency with operations, with flight and traffic management improvement. And to make this happen, actually, we really need innovating and leveraging the digital continuity to make sure that all these solutions could be scalable in the ecosystem value chain. To really achieve a net zero emission for the overall aviation, we will for sure need a mixture of technological solutions just to be able to cover the full scope of flying vehicles. If you take on one hand limited number of seats or limited range, for sure the solution electric batteries can be a solution. On the other hand, with long-haul flights, the solution is to burn a cleaner fuel, either sustainable aviation fuel or in the future hydrogen. With this technological solution in mind, let's refocus on hybrid and particularly what is needed today for making it happen. So Jean-Christophe, could you please tell us what challenge Ascendance will face in the upcoming months and years?
Yes, sure. So since we signed the partnership with Capgemini, we have been investing a lot in the research and development. So today we develop up to 7 prototypes, be it on the aircraft side or at the hybrid propulsion system itself. So today we have been running some tests at scale on the hybrid propulsion system for 1 year now. And we'll focus in the next 2 years on making fly our first prototype of the aircraft, planned in 2024. And from that prototype, we learn a lot on the industrialization, but also on the certification of the technology. So for the battery, for instance, we know that today it's key for the certification to avoid to have some thermal runaway. It will be key also for the thermal engine systems, for the high voltage systems. So we learn from the technology, from the test, to then better plan and go deeper into the certification and industrialization phase.
That's really impressive that you're already scaling up just after 5 years of existence. So What made Ascendance grow so quick? Could you just explain the role of digitalization in your development?
There is many reasons. One, as you mentioned, is digitalization. So from day one, we leverage what we call a digital twin. So we modelize, we use a lot the simulation and modelization, and we iterate with a lot of experimental data. For instance, we use a lot of CFD for the aerodynamic, and we perform 2 wind tunnel testing to compare the experimental data with the modelization. Same for the hybrid system. I mentioned previously that we have a full-size test bench, and each time we go deeper and deeper in the detail of the modelization to be able to go quicker to the certification and to go at a higher speed for the next step of the development. Another reason is also to leverage the capabilities of our partners. For instance, Capgemini, we got a lot of discussion on different areas of development. Digitalization is one, but manufacturing is also one. And I think as a French startup, and with regard to the history of French aviation, we have a very, very amazing ecosystem that we need as a startup leverage to be competitive and to go as quick as possible to the market.
Indeed, it's only 2 years we are partnering together, but to be honest, it's gone so fast this period, and we've faced different amazing periods, both with human and engineering challenges. Dealing with Ascendance prototypes, it's for sure pushing the technical limits and also bringing lots of unforeseeable situations, and everybody on the project has to work out of its comfort zone and to invest personally to learn as quickly as possible. So that's really a great period. Initially we thought it was impossible, but they did it. I could have talked about different topics we've treated on hydrogen, hybridization, batteries, acoustics, and I've chosen only 2 examples which are more representative. The first example is on wind tunnel test campaign, which is really a key step in the development process and on the design process, with the objective of assessing performance and handling qualities, for understanding the physics behind, and for validating the models and that were initially produced with numerical methods. So on this kind of campaign, the main technical challenge is to respect the rules for managing the scaling effect. And we've faced a challenge that is undoubtedly the project management, with many components, many players, with really an aggressive timeline. And on the D-Day, in the wind tunnel test, when the flow is blowing, the only way to succeed was to rely on the ability of the team to adapt. The second example is on the development of the electrical power generator, which is at the core of the hybrid propulsion system. The objective were to validate the design, the assembly, and the integration of each component while ensuring safety and operability. Test required lots of system tuning in a very short time, and I think on that we've demonstrated very strong resilience of the team, able to invest personally, to connect with Capgemini experts, and able to keep calm whatever situation by applying rigorous system engineering methodology. I think these examples are perfectly illustrating our daily engagement as business partner for next generation aviation, and it shows how crucial it is to bring all expertise together and also to create a condition for innovation to emerge faster.
Absolutely. As I mentioned before, the ecosystem is key for us, and especially as we go deeper and deeper in the industrialization and into the certification process, we need to have access to a lot of expertise and resources. And I see partners like Capgemini as an accelerator to go to the market and facilitator to have some success.
Thank you, Jean-Christophe.
Thank you, Mylène.